All right. Is this on? All right. So I think we got 1 minute left, so we can start it. People that will be eventually join us can catch up. And there's one interesting to see here. One of those mistakes that the speakers do before they do a presentation, like I had all my Docker images already built, and then I decided to change a piece of code, remove the Docker image, and then, all right, I'm just rebuild it. The chances of the demo to actually break is going to be higher, right? So bear with me if it doesn't work. But presumably the Docker containers are up, so let's just double check here. Yeah. So meanwhile, let's get started. All right. So thanks everybody for coming in. This is probably the last, probably not. This is the last session of the day, right? So I'm pretty sure everybody's tired, so I have a tough job to do, which is keep you awake until the end, right? So this presentation is about distributed tracing, right? But I'm going to try to do something different from at least the sessions that I've seen before regarding distributed tracing, which is focusing more on the concepts and the theory behind it, and of course, technical implementations as well, but focusing on what is the actual journey for you to start using this technology, right? And the reason for this is quite simple. I've been using this technology for quite a while, and every time I actually try to work with customers or talk with people, I've noticed one pattern, which is, right, people conceptually understand what distributed tracing is, but when you start digging deeper, you start seeing some holes in the understanding, such as how the traces are propagated and what is the concept of context, right? So this is what I'm trying to address here, right? I'm going to use one of those techniques of, right, let me share something personal before starting the presentation. And I would like to start with this, and you're going to understand the meaning of this in the end, which is I'm fascinated about criminal investigation TV series and movies, right? So for those of you that remember the famous movie Seven, right, with Morgan Freeman, Brad Pitt, so this is an example of movie and TV shows that I like to watch a lot. And the reason why I like it and why I've brought here today is because I think they are not seen, right? Oh yeah, thank you. All right. I think that's the perfect time to use one of those Zoom meetings that we say, can you see my screen? Can you hear me okay? Right? Is the mic on? So things like that. I've been doing this for 2 years, so I think I've missed it. By the way, thank you everybody for coming here today, because that has been 2 years since the last time I gave a presentation personally. So this is quite a few things for me. So criminal investigation, for those of you that want to dig deeper, obviously is not the focus of the presentation today, but it is a discipline. I actually understood that applied science, believe it or not. Criminal investigation. So we have to actually, there's a whole science behind it, right? It comprises all of those characteristics over here, right? Which through the course of this presentation, I'm going to try to highlight each one of them, because believe it or not, they has everything to do with distributed tracing, right? So when you are doing distributed tracing, you are doing, for example, forensic science. You are doing the creation of timelines, exercise. You know those detective shows that they basically start creating a timeline of events of after they discover the suspects and collect the evidence. This is essentially what distributed tracing is all about, right? So I'm going to highlight what this has to do through the course of the presentation. So the agenda for today is simple. What is distributed tracing? I'm going to try to explain what it is. So for those of you that are new to this technology, my hope is that you understand what is this about. For those of you that are already familiar with, I'm trying to fill one of those holes that I've mentioned before about how it works, right? Because here's the thing. You might be using some distributed tracing technologies already, right? You name it, Jaeger, Zipkin, Datadog, right? Elastic. But the only thing you know is that you've installed an agent in a host on a container, and all of a sudden, magically, all the traces are ending up in the backend, right? So what is the medium term about how this happens? So this is what I'm trying to focus here right now, right? And obviously, we're going to discuss the benefits. And I think this is important because I've noticed that some people, specifically people from the ops team or SREs, they have this difficulty of justifying the usage of distributed tracing in their teams and their companies, right? So I'm going to try to highlight some of the benefits if that might eventually like help you with this argumentation with your teams, right? And then finally, we are going obviously discuss some challenges, right? Because this is something that I've learned that people would like to hear, right? So everybody talks about the excitement about distributed tracing, all the cool things about it, but nobody mentions about what is the actual challenge, it's the ugly stuff, right? So we're going to discuss here as well, right? So for those of you that don't know me, my name is Ricardo Ferreira. I work as a developer advocate at Elastic. I'm part of the community team. I'm part of the developer relations team. And before Elastic, I used to work for Confluent. So I have a background with Apache Kafka and dealing with Apache Kafka with communities and before Oracle. And then a long time ago, it sounds like a long time ago as well. Like I used to work for JBoss before the Red Hat acquisition of JBoss. So I have basically my background is all about data, middleware, and messaging. So, and I don't know how I ended up working with distributed tracing to be honest with you, but it seems to have some similarities with those technologies, right? And if you use Twitter, it's not showing up here. Sorry about this, but it's at Ferreira, right? So I'm going to provide here in the end. Or you can just go to my blog and my Twitter handle is going to be there as well. Actually, this is my Twitter handle, just my blog name, host name, at Ferreira, okay? All right, let's get started. What is distributed tracing? First of all, it's not something, it is actually new. Yeah, surprise, surprise, right? So this is something that we as technologists, practitioners, and developers have been doing for a while. Just the name has changed a little bit, right? It's just like the famous joke that I've seen Twitter a while ago that people start calling everything about observability, right? But why? Because it's a cooler name than monitoring. Because it sounds cool, it sounds sexy, right? Instead of calling monitoring, right? But distributed tracing is something that everybody used to do in the end, right? Either if you were intentionally done this in the past, or if you haven't done this intentionally, it's supposed to work with as a logging mechanism, right? So we used to define our logs, right? And then throughout the code, we would, as developer, write those entries in our code, or if you were not a developer, you would ask the development team to insert some of these milestones in the code. So by the time the runtime environments actually execute the code, people from the ops team could actually see what's going on in your code without necessarily having access to your code, right? So we're talking about troubleshooting, right? So troubleshooting, not necessarily today or these days, I'm gonna talk about this in a minute, but used to be what we used to call follow the thread troubleshooting technique. I've heard about the term follow the thread, right? Why is that? Because let's go back in the time, right? Let's pretend we're on a time machine and go back to the 90s. And then we used to have those web servers, right? Apache HTTP web servers, where every single transaction would come in and would be translated to a thread to the operating system, right? So basically how you would troubleshoot things, you would follow the thread. The thread ID would comprise all the logging entries, and somehow they would be stitched together, either because the developer wrote the code to stitch them within the thread, or because they would be used to be using some logging frameworks that would be doing this automatically. Like for those of you that come from Java, Log4j does this, for example, right? Or Golang, they have the built-in log package that does this as well. They stitch all the execution code within Golang doesn't call threads, they call Go routines, but you got the point, right? So the point is, basically, every transaction is a thread. Just if you want to troubleshoot things, follow the thread, right? And then we start seeing this like patterns, or should I say anti-patterns of developers trying to stitch the whole architecture. Because since the early days, we as practitioners or technologies or developers, we used to break up the domain model of an application into multiple smaller domains, right? We're not yet talking about microservices, but used to be smaller domains within the same application, right? Maybe breaking down using multiple modules or packages, right? The point is, for the logging perspective, you would end up using the same approach, right? You would end up stitching those domains within your log, because ultimately, let's recap, you would start using the follow the thread technique, right? So you need an observable way to look to the thread and understand the whole transaction from the point of the log, right? That's the point, right? However, some changes in our industry started to happen. The first one is the big boom of virtualization, right? Someone detected that, yeah, we are overutilizing the machines, right? So we have a machine, powerful, lots of memory, lots of CPU, lots of network, but we're not using a lot. So let's do the consolidation of multiple virtual machines on top of VMs. Great, solve the problem of underutilization. However, create the problem of it create a troubleshooting exercise more longer, right? In other words, if you want to troubleshoot things, it's no longer SSH into the host machine to follow the threads. Now you have to SSH to the host machine, and then you would create a bastion server to SSH into the VM, and then you would follow the thread, right? So complicated a little bit. And then someone decided, yeah, but you know what? I think we should solve also the problem of creating golden images for our deployment purposes, because there's this difference between how the development environment looks like and the production environment looks like. So let's solve this using the concept of images or containers, which is exactly what I was trying to solve in a minute, right? And then we create the containerization word, right? Awesome, amazing, right? No doubt about it. However, one more time created a new complexity in how people troubleshoot things, right? Now you have to do multiple jumps, right? Connect to the VM, connect to the host, connect to the container, and then you're gonna have access to the code, right? So the point I'm trying to make here is that we are, as an industry, we are starting breaking down the domain into multiple, like, smaller pieces, and nowadays we have serverless, we have function as a service, and then all of a sudden, we are creating complexities that indeed they are solving other problems that the industry has, like virtualization and containerization or functionalization, if that is actually a word. However, right, we are creating extra complexity about how we are going to stitch a transaction from the logging perspective, right? And for those of you that likes, actually, this is supposed to be what I was telling before about the advent of containers. Now we're talking about functions, and then, right, everything like this extra, like a overcomplication of things is creating some damage in how we troubleshoot things. So the point I'm trying to make is that distributed tracing is a pragmatic way for you to do this stitching, right, of your code, even though you are running in a single host or in multiple VMs or in multiple containers, or perhaps you are maybe using AWS Firecracker and you have functions spin up every second, so the life cycle of each container is unpredictable, right? But still, you would have to actually create this trace between all of the code, right? So this is what distributed tracing is all about, right? Everything else that you might have heard about distributed tracing is a benefit, right? But the fundamental problem that you are trying to solve is how to keep track of my transactions in a distributed environment, right? And it is not a coincidence that the word is distributed tracing. To be really honest with you, I don't like that word very much, because I have seen some scenarios where you can use distributed tracing even though the application is not necessarily distributed, right? I'm going to give it some examples later on. But there's some benefits if you have a monolith, for example. Instead of you maybe hooking up your IDE and then download the last version of your code and then set some breakpoints to the code and then hook up to an external process remotely, you can use distributed tracing for this as well. It's a way for you to debug code, okay? All right, so keep that in mind. Now, if you follow the approach here, those are the three characteristics that we're talking. How distributed tracing are gonna make you a criminal investigation for incidents in production, right? So you are basically collecting evidence, right? And the evidence that has been collected, you are able to search them, to make questions, to answer questions, and you are also being able to interrogate your systems to the purpose of trying to understand what's going on, right? So distributed tracing is a way for you to kind of play as a detective for problems, right? All right, how that works, right? So everything, this is the best way that I've found how to explain how distributed tracing works. It's all about the context, right? Regardless of the implementation. Oh, Ricardo, there's a difference about how Zipkin and Jaeger and Datadog or Elastic works. All of them create something called a context, all right? What is a context? Is a unique identifier for your transactions, all right? So what happens behind the scenes is that by the time your transaction starts, and the whole concept of the start of the transaction varies, right? For example, you might have created an Node.js application where the user starts the transaction by clicking a button, right? So this is your transaction start. Or perhaps your transaction start might be an API that has been invoked by a partner running in another data center. Regardless, by the time your transaction starts, a trace ID is created, right? And the whole purpose of distributed transaction is to pick up this trace ID, which is unique for transaction, is a one-on-one relationship, trace IDs and transactions, and propagate across your stack or your application or your architecture, right? And how this happens varies depending on the implementation, but usually is via a process called instrumentation, right? So instrumentation is what takes place on each layer of your architecture, each service or each API, each data plan of your Kubernetes cluster would have a instrumentation in place, and we're going to discuss later the types of instrumentation that there is. That's going to take care of this. Ultimately, what the instrumentation is doing is making sure that trace ID is replicated across all the transactions. And sometimes this is simple, sometimes this is more complicated. Oh, Ricardo, can you give me an example of simple scenarios that the replication of the trace ID is simple? Yeah, HTTP requests. It's all text. HTTP request has headers, so the instrumentation only needs to create a header entry, insert the trace ID there, and move forward with the implementation. That's simple. gRPC, the same example. However, maybe you are using microservices that communicate over Apache Kafka or Apache Pulsar or RabbitMQ. So those technologies has the concept of producer and consumers, and those transactions are running in their own threads, right? So how are you going to propagate the trace ID if they're not running in the same thread? So those are the scenarios where sometimes the process of replicating the trace ID is more complicated. But ultimately, what's your job as a distributed tracing developer? Propagate the context, right? Ricardo, what happens if you don't propagate the context? You're going to have blind spots, right? So whoever is troubleshooting or debugging your system or application in an observability backend, for example, is going to start to see the whole flow of the transaction, but all of a sudden is going to see, okay, instead of all of a sudden the flow jumped from the service A directly to service D, and what happened with service B and C, which I know that are part of the transaction? Well, the trace would not be able to be propagated. So that's the importance of making sure the context is propagated to all the layers, right? So ultimately, the tracing process is all about picking all the traces, right? So those are the example of traces for each one of the layers or services of your architecture. And you're gonna have this entity, let's call entity for now, right? You're gonna have this entity called tracing pipeline. This is a virtual representation. It can have different shapes or different implementations, but the responsibility of the tracing pipeline is huge because it has to receive the traces. It has to be extremely reliable. It has to be extremely scalable. Why? Because if you lose a trace, you're gonna end up jeopardizing the whole observability purpose in the backend, right? So it all of a sudden cannot simply lose traces. So that's the first, right? Secondly, it has to put all the traces in place, right? Why? Because the traces are not going to be all the time sending in a specific order. Like, for example, if you look this diagram over here, you clearly see that the first invocation goes to A, then calls service B, then goes service C, and then calls service D. Very simple because it's visual, right? However, behind the scenes, remember those agents from Zipkin, Datadog, Elastic that you install? They don't send in the sequence. They send best efforts in a random order. So it is the responsibility of the tracing pipeline to receive them, sometimes maybe buffering for a while to keep them in order, right? This depends on the implementation. Some vendors also use the technique of, all right, I'm not going to do anything in the tracing pipeline. I'm going to simply receive, buffer, and then store in a data store, whatever data store it is, right? And then the data store is going to do the process of stitching them together in the order, right? So that's the part where you're going to see different variations of the implementation. But ultimately, what we are doing here, we're shifting responsibility, Either this is the responsibility of the tracing pipeline, or this is the responsibility of the data store, right? What's the difference? How to choose from? Well, which one you are more comfortable with, right? Maybe you are part of a team that has more experience with relational databases or NoSQL databases. And then that's the part where you might be inclined to pick up this kind of tracing strategy, right? Or maybe your background is messaging or streaming technology such as Kafka or RabbitMQ. Or perhaps you might be inclined to shift this responsibility to the tracing pipeline, right? Because your team is going to be able to troubleshoot better on that place. So you see how some sort of a culture also takes place when you are adopting distributed tracing, right? Because this is the part that I've seen in my experience that, all right, certain teams, right, kind of a dislike distributed tracing because ultimately they're dealing with a specific type of architecture or topology or architecture style that they're not used to it. And sometimes this is just a problem, right? Well, another point about how things work is that everybody, this is something funny, but everybody that tries to explain observability, how people start explaining observability, what is the first words that came out of their mouth when they start explaining, oh, observability is about the 3 pillars. Anyone? No? All right, 3 pillars, right? Which is metrics, logs, and traces, right? So, which is not wrong, okay? It's not wrong at all to start explaining observability this way, because indeed they have 3 pillars, right? The problem is that the perspective about how do you see metrics and logs and traces, they're not silos. They should not be treated as silos. And what we've seen out there is that, oh yeah, I have a whole architecture and team and set of processes dedicated to logging. And I have another team and set of processes and technologies focusing on tracing. And then same goes to metrics. I have a whole team expert on Prometheus to handle metrics, right? This is the part that I personally disagree. Because when you bring them together into the same word, and that's the word that I like to call observability, right? Where metrics, logs, and traces, they have a connection, they have a correlation, right? You can answer questions faster and better if you actually correlate all this information, right? So the point I'm trying to make here is that in order to accomplish this, you're gonna have to use a data store that is capable of doing this, right? And this is one of the common problems that I've seen out there. For example, I've worked with, back into my consultancy days, I've worked with a company that adopted Zipkin for their tracing implementation, which is fine, perfect. And Zipkin is cool because it has a flexible architecture where you can plug any type of data store. It's amazing. You can use SQL databases, you can use NoSQL databases, Cassandra, Elasticsearch, or whatever, MongoDB, or you can use even other technologies that are Kafka, for example, right? And then the point I'm trying to make is that they've decided to use Kafka as the backend because Kafka is scalable, and it is, right? I know this because I used to work for Confluent, and I was in the first place how Kafka works. But the problem is this: Kafka is a streaming architecture which is perfect for logs, right? But metrics, what is metrics? It's time series data, right? This is the arena of InfluxDB, for example, right? What is the other database that is also very cool in terms of time series? Besides InfluxDB, there's another one that's very famous. Which one? Yes, exactly. Thank you. So that's the part where when you were deciding what data store you were going to use for your observability purposes, you have to take this discussion upfront, not later, right? Because later can be too late, right? And you have to think ahead about what type of data store, because ultimately the data store will play a crucial key in about how your observability adoption would take place, right? So TLDR is not just about picking the right database for tracing or the right database for logs or right database for metrics. You have to be one that preferably has the ability to actually afford all of them at once, right? So if you look at closely, distributed tracing allows you to create timelines. We've seen a timeline before, right? And actually that's the demo that I would like to show right now as a pause for you to see a real example of timeline. And you are also able to do forensic science, which is investigate a little further by the examination of the evidence, how the traces kind of create this relationship between them, right? So if, right, let me take a pause here on the presentation. If the Docker image that I was trying to build before is working, we're gonna be able to see some over here. So this is an observability backend. I probably am gonna need to increase the font size a little bit, right? Better? Yeah. Presumably it's working, so let's see. So I have a transaction here, which is called reload app, a little bit higher. So people in the back are able to see here. It's good. So this is a microservice that I've wrote in Java, very simple, hello world basically, right? And then this microservice has a transaction called hello, right? And the source code I'm going to share in the end, so you're going to see this. There is a Docker Compose here that essentially this Docker Compose, where is? Here we go. This Docker Compose every 10 seconds is invoking that endpoint, and that's why you're going to see a lot of invocations here. So you have in a single glass pane, right? All the SRE word called this golden signals, like error rate, latency, throughput, and there's a saturation, right? So you have all this metrics accumulated, and you have here the actual transaction, or let's say set of transactions that have been executed. And this is the timeline, all right? So this is what's supposed to be the traces that has been received, and the observability backend, which in this case is the Elastic Observability, managed to stitch them together and find the relationships. And what is the relationships in the end of the day? What is the little thing that every single trace, actually just give it up the name, but what is the little thing that every piece of the string contains is a trace ID, right? So if you come from the database word, you could translate this to a select join. It's a join. You're joining multiple traces, giving the foreign key that uses the trace ID, right? So that's basically one way to do it. Okay, so let's move forward. We're gonna go back to this demo in the end. So I just like to highlight here the point of you were able to create timelines and forensic evidence. So benefits of tracing, right? So just we keep that in mind. There's a lot, we're gonna discuss some of them, but if you ask me, Ricardo, you give me your opinion about what is the most amazing value of adopting distributed tracing. And in my opinion, right, it is the ability to decrease your troubleshooting cycles, right? Everybody virtually agrees with this. Performing troubleshooting sucks, right? Sucks because it's difficult, it's not sexy, right? Most of the time you are in a hurry. Most of the time you are being kind of requested by your whole team, or maybe your product owner, your product manager, to hurry up, man, because we're having downtime and our customers are unsatisfied, right? So it's not a very pleasant situation to do troubleshooting. And in my experience, troubleshooting has three phases, right? There is the suspicion phase, which usually comprehends 10% of the time. Suspicion is I'm looking to the dashboards, maybe Grafana, Kibana, I'm looking to making Nagios. Remember Nagios? Used to be very cool back in the days. And then I'm using some alerts that are telling me that something's off or something's not right, right? So this is suspicions, right? You usually 10% of the time. And then you are going to end up with 60% of the time doing the drilling down, right? Why drilling down? Where the problem is, okay? Ricardo, why I'm gonna spend 60% of my time knowing where the problem is? Remember the containers, serverless, virtualization, multiple machines, multiple data centers. Now in the era of cloud, multiple availability zones. Damn, it's so complicated to find where the problem is because the architectures these days are becoming so distributed, right? So this is the part where, in my opinion, we spend the most of the time, because by the time you know where the problem is, right? The solving part usually is 30% of your time. Yeah, it's not, I'm not saying that's easy, right? You still have to maybe create some fixes on the code. Perhaps you don't understand what the code is doing, and then maybe someone else did and push that, you know, that late nights push that you go to GitHub, and then it's midnight and everybody's tired. I'm gonna push this, and then tomorrow I'm gonna break up, and then I forget to actually fix that problem, right? So this is the type of situation that I would say that it's easy, right? Double quotes, but here's the trouble part. And tracing helps you with that, to minimize that window, because it gives you a zoom where the problem is. The industry call, it helps you with the MTTR, which is mean time to resolution, right? So if you are able, using distributed tracing or some other methodology or technology that helps with that, I think that's what makes the most successful SREs and DevOps teams. Because in these days, everything is all about 99.9999% of availability, right? Downtime is not tolerable anymore. Remember back in the days where you were surfing a website and it was down and it was okay? We used to tolerate that. These days, the first minutes that, not minute, the first second that something is down, you can check on Twitter that everybody will be complaining about it. Now, this is something that is not so important as reducing MTTR, but I found historically that this is another benefit that if you start using distributed tracing, you can benefit from, which is, I'm gonna tell a story. I used to work for Oracle in the past, and Oracle, believe it or not, they used to have a distributed tracing technology. It's called, used to be from a company called Umberpoint that they've acquired. And then they rebranded to something called Oracle BTM. I think it's Business Transaction Management. It was a distributed tracing technology. And I was working with a telco customer from Brazil. I'm from Brazil originally, by the way. And we were investigating a problem that all of a sudden we would have this slowness. Nobody could explain why all of a sudden there will be this slowness in the architecture and the environment, because they were using some, remember those EXA machines, EXA data, EXA logic, everything over beefed for computing power. And all of a sudden, the latency would decrease and the throughput would decrease, right? So we decided to install Oracle BTM, which is the tracing technology, to investigate further where the problem is. And then what we found is that as part of the transaction that was executed in production, not on Q&A, not on stage, not on development, but in production, there was some calls for staging servers, right? So we found that some developer hard-coded the endpoints of microservice, or I don't remember what was that back in the time, but it was hard-coded to always invoke to the staging server, was not pointed to the production server, right? And this is the type of thing that you can look to a log the whole day, a log, standard log, and you're gonna be able to find that information. But if you look to a, oh, sorry. If you look to a trace like this, you're gonna say, okay, what is this? Okay, what is this call over here? And you can see everything, like the endpoint, the host, the container. So, and this is the type of, I'm gonna call it mistake, but I treat this as a human mistake because we are all humans. Every release, maybe we're gonna ship problems like this and we're gonna create incidents, right? Even unnecessarily, but you're going to be able to find differences between releases, because ultimately all the traces would be stored on the data store, and you can, most of the tracing technologies allow you to do this. You can create, okay, I'm going to compare this release from 3 months ago. What changed, right? And you can compare the timelines. So this is a cool thing for you to actually find problems, right? And another benefit is, remember when I show you the, in a single glass panel, you can see the metrics, you can actually see the logs, and you can also see the traces in a single panel. It creates more team collaboration. And I think this is very useful because what I've seen out there, right? I'm not saying that this is wrong, right? Or that I disagree with this approach. It's just how people do, how they decided to do things. I've seen silos of teams when it comes to observability, right? Just like the example that I've mentioned before. I've seen teams dedicated to metrics. I've seen teams dedicated to tracing. And obviously I've seen teams dedicated to logging, right? And when you have that famous incident occurring in production, what is the first instinct of everybody? Put everybody in the same room, AKA the war room, and then we're going to debate where the problem's coming from. But each one now has their own perspective of the problem, right? So when you start using distributed tracing in an approach that can consolidate all of them in a single panel, I think that promotes a better collaboration, right? I would say no need anymore to actually bring everybody to the war room. They are always in the same war room all the time. They're looking to the same information. So no need for me to expand like 2 hours explaining what I've done in the metric side, so the other team from the log side can understand what I did. You know what I mean? Everybody is always in the same page. So I think that's powerful. That's something that we should pursue as well. So what we are talking about here is motive probing and human psychology. In the end of the day, the famous pointing fingers in a war room, it should not occur very often, right? And ultimately, usually in detective shows, you have that when the actual detective or investigator, they actually know who did the crime, they have all the evidence, but the suspect needs to go to a trial, right? And they have to build a very strong case so the trial can actually be, I don't know, I forgot the word, it's not incriminate. What word we use when we used to say a suspect actually is proven that's committed a crime? Where the jury decides that he is guilty. Yeah, convicted. Yeah, it's a conviction. Get a conviction. I think that's conviction that he's guilty. Yeah, exactly. So the detective has to help in the process to the lawyers to actually build a strong case, right? And distributed tracing helps you as well as developers and practitioners, because ultimately sometimes we are forced to justify things to upper management, to other teams, to other companies, sometimes even for the actual customer, right? So tracing also helps you to build a strong case about what's going on, right? So I think that's also powerful. So as I mentioned before, it ain't all flowers, all right? Tracing also has some challenges that often we need to surface. So I'm gonna explain some of them. First of all, our natural instinct, right, as practitioners, as technologists, developers, and SREs, teams, is to pick up open source, right? After all, what is the name of this conference where you're participating here? All things open, right? And what I've seen out there is that most of the time, although our instinct is to favor open source, sometimes it's not possible, right? So I'm going to discuss some of the situations that I've seen before. If you ask me, what tracing instrumentation library or framework or SDK should you use for new brand projects is called OpenTelemetry, right? This is a CNCF project. It's going to ensure that your instrumentation process or coding for instrumentation is going to be vendor neutral. Awesome, amazing. There's only one problem though, right? Because the project is quite new. It has 1.5 years, I think. OpenTelemetry, just for starter context, is the evolution of open tracing and open census, right? So those projects has been retired and then they merge into OpenTelemetry, right? It is amazing. This demo that I've created here uses OpenTelemetry. So the GitHub repository I'm going to share later, you can follow there to learn about it. Point is, OpenTelemetry is not mature enough for all the programming languages, right? It's sad, but it is. Java, amazing support. Golang, amazing support. Node.js/JavaScript, amazing support. PHP, Python, C++. So this is the type of situations that, all right, I want to use open source, but the support of the libraries for a specific programming language are not that mature. And that's the situations that I've seen that people kind of a shift towards, all right, I'm going to end up using a proprietary implementation. So bring that discussion earlier, okay? Another point, frameworks versus libraries. So here is the thing in my experience. I've mentioned OpenTelemetry, amazing technology, right? Do use OpenTelemetry as much as possible. There's only one heads up. It is a framework. It is not a library. You know what that means? It means this as a framework, it's supposed to accommodate many different use cases. It's supposed to be extensible, right? It's not necessarily built to be easy to use and follow and adopt because the extensibility, all right? So a lot of complaints that I've seen in the past is that, hey, Ricardo, I tried to use digital tracing, but it's too complicated. You know what? Perhaps you were trying to use a framework instead of a library. For example, if you're trying to adopt a New Relic SDK for open tracing, for distributed tracing, it is amazing. It's very simple, right? Because it is a library, not a framework, right? So this is the type of thing that sometimes you might choose to use what is easier to you, because what I've seen out there is that perhaps the development team is not mature enough to actually learn how the extensibility works, right? So this is the thing, unfortunately, right? Data store scalability. I've seen some situations where I think the value of observability when you comprise logs, metrics, and traces in a single place is when you are able to compare whatever's going on right now with the past, right? So what I mean by past, it would be useful if you could compare, for example, a release of a tracing of a transaction that you have stored in the data store from what 6 months ago what you used to look like, right? In order to accomplish this, you have to have a data store that is capable of storing this for 6 months or maybe a year or maybe years, right? However, this is the part of, and we're going to discuss sampling in a minute, this is the part that every single implementation that I've seen out there and a company that adopted this trace decided to do. Okay, because of storage costs, because of networking costs, because of compute costs, we're going to decide to only store the last 3 months, and then we're going to get rid of it and roll out all the traces that we have there. The trigger is always the same, costs, right? Or sometimes, because the data store or the engine use it as a backend, has a cost associated to store more than that time frame, right? So the point is, sometimes the scalability problem of the data store can be something hurtful for your adoption, right? Perhaps is related directly to cost or indirectly, right? And also architecture fit. It's very common. We're gonna give another example in a minute about sometimes distributed trace is not only compatible with your architecture or application, right? Ricardo, can you give me an example? Of course. In the past, remember that when I used to say, I give the example of follow the thread troubleshooting, right? Everything would run in a single thread, and that thread would be pinned to a host or perhaps a VM, right? And then it's not necessarily distributed, and some instrumentation libraries or tracers, as we call it, they require all the application to be actually distributed. For example, I'm going to give you another example. It's very common nowadays that people are adopting service meshes, right? Kuma service mesh, for example, from Kong or Linkerd or something like this. It is the perfect ecosystem for you to enable tracing on the hood, right? Without necessarily changing the code of your microservice. Amazing. There's only one point that you have to take care of. All the communication has to pass through the service mesh. That's a pre-requirement, right? Or maybe you are dealing with an application that's not passing through the service mesh. What can I do? That's a problem, right? So architecture fit is a thing when you are adopting distributed tracing. And there are two terms that I would like you to, if you forget everything that I've mentioned here today, except for the detective TV show that I've mentioned before that you know that I like, right? There's two concepts that you have to kind of, there's an expression that we use when we kind of stick in your brain. It's an American expression. You have to, what is the expression? When you have to make sure that it's stuck in your brain in such a way that you will never forget. Oh, come on. No? Okay, we're gonna come back to this later. There's one thing that you have to remember is this. There's two types of instrumentation, black box, white box. Without thinking any further, which is the best one? White box, right? If you have to remember this, is this. If you have the chance, always choose white box instrumentation. What is white box instrumentation? The name says everything, right? You don't treat your application or code or microservice as a black box. You're gonna open that code, you're gonna change the code, you're gonna put some entry points or libraries or hooky points to do the instrumentation for you automatically. That's how you end up with the most visibility about what the code is doing, right? Sometimes this is not possible. Sometimes I cannot change the code because I don't own the code, or I'm not supposed to change the code because otherwise I'm gonna be in a bad shape with my manager, right? So what people do is using one of those smart agents. For example, Java has this concept of agent, right? You can use a jar file. You can use an agent that's going to kind of insert some bytecodes dynamically in runtime so the developer doesn't necessarily have to insert code for it, right? So this is what we call black box instrumentation. It works, of course it works, but it's limited visibility, right? So keep that in mind. And another thing that is important, we're almost hitting the end, we have 1 minute. It's, in the past, web application used to be quite simple. A browser, in a web server, right? But with time, we as a community of developers, we learned that we can put some code running in a browser. So there's a lot of frameworks for web development and web frameworks these days, right? Every single week, we know a lot of new Node.js flavor that's popping up out there. So it's quite complicated to put some tracing code that runs in a browser. There's a lot of complication. We could spend a whole day so we can discuss what type of complication pops up when you are actually trying to merge tracing from the front end with tracing from the back end, right? But the reality is that the implementations are not very mature enough, just like the open source implementations, right? And sampling, just to wrap up, sampling is the process of, let's say you execute, the customer executes 5 transactions, right? Just to give you an example. One way to handle tracing is every transaction translate into a tracing, right? But what if you are dealing with a scenario of high throughput where you have 5,000 transactions per second? Are you going to generate 5,000 tracings per second and send to the backend? Again, the problem of compute, storage, and networking costs, right? So a way to overcome this in distributed tracing using the concept of sampling. Every instrumentation library, every vendor has this, right? We call sample strategies. There is the probabilistic strategy. There's the tail strategy. That is these, you can set a ratio and percentage of how many traces you want to get, right? So the point is a trade-off between scalability and costs, right? So that's the thing as well. All right, guys, wrapping up. I would like to share with you this GitHub repository here, which is the code that I've used in the demo. I think the best part of this code is that it's all based on open telemetry. So, and I've tried to make as simple as possible because most of the demos that I've seen out there, they are complex, right, to understand. And what you want is actually understand the open telemetry part, what is actually the code. So this is an example that has this, and I would also recommend 2 things. Go to this Slack channel over here, that CNCF channel, and join the open telemetry channel, right? Get part of the community that discusses the future of open telemetry. Not open telemetry specifically, but tracing itself, right? TLDR, open telemetry is how you're going to handle telemetry data, whether if it's metrics, traces, or logs, right? So you do want to actually be part of that community. And with that, thank you very much for your time. I think we are on time, right? 2 minutes later, but, and if you have any questions, I'm more than happy to answer them if you want to. Otherwise, thank you for your time.